Tikkas, lecturer of Electrical Engineering Department of Praveen Patel College of Diploma Engineering and Technology. Next topic is commercial installation. So in commercial installation, earthing is very necessary. It's a very need. So let's see the need of earthing of commercial installation. So first one is to provide an alternative path for leakage current to flow towards the earth. Second one, to save the human life from danger of electrical shock due to the leakage current. Then third one is to protect the high risk building structure against the lighting stroke. Then to provide the safe path to dissipate lighting and the short circuit current. And last one is to provide the stable platform for operation of sensitive electronics equipment. So therefore the earthing is very necessary of commercial installation. Next point is what are the methods of the commercial earthing. So earthing of the commercial installation is very necessary to save the human life at the time of ground fault. There are two methods of earthing. First one is plate type earthing and second is pipe type earthing. And the earth resistance for the commercial installation should be in between 5 to 8 ohm or less than it, not exceeding 8 ohm. The earth resistance to measure by the potential drop method or tester method, or earth resistance is maintained by pouring the water in earthing pit. And next is size of earthing is 18 SWG copper and 16 SWG GI for the lighting load, and the size of the wire 8 SWG of copper and or 6 SWG GI for the power or machine load. So it is very important. And these are the methods of earthing of commercial installation. Now next is what are the example of commercial installation. So office is the example, then school, mall, big temple, then colleges, theater, etc. These are the examples of commercial installation. Then what are the requirements of commercial building. So first one is find out the requirement, or it is also called as a procedure. So what are the procedure to install the commercial installation. So first one is find out the total electrical load for given commercial installation. Then differentiate this total electrical load in the lighting load and the power load. Then find out the lighting sub-circuit for the lighting load. That means number of lighting sub-circuit is equal to total electrical lighting load divided by the 800. Then number of lighting sub-circuit is equal to total electrical lighting point divided by 10. Then fourth one is find out the power sub-circuit for power load. Number of power sub-circuit, how to calculate? So it is equal to total electrical power load divided by 200 or 300 watt, or in a points. So number of power sub-circuit is equal to total electrical power point divided by 2 or 3. Then next find out the types of load and the power factor of commercial installation. Then next one is find out the rated input current for every lighting and power sub-circuit. So for calculating the power, first this is the formula. P is equal to VI cos phi. P is the input power of every sub-circuit and for the single phase supply voltage is 230. So after rearranging the term in this formula in terms of current I, so input current I is the input current for every subcircuit, so I is equal to P divided by V into cos of phi. Then find out the total power of every lighting and power subcircuit. Then determine the size of wire required for the every subcircuit by considering overload, starting surge and future expansion. Then next, balance the load on every phase for commercial installation, or some take safety precaution, fire extinguisher, then smoke detection system, and last one is fire alarm system. So these are also balancing the load. These are the balancing the load. The next is rules and guidelines for installation of commercial electrification. So first is every installation is to be properly protected near the point of every supply cable by a 2-pole link main switch and fuse unit. In a 2-wire installation, if one wire is permanently earthed, no fuse, switches or circuit breaker is to be inserted in this pole. A 3-pole switch and fuse unit is to be used in 3-phase supply. Second guideline is the conductor use are to be such that size of conductor should be carry rated current and partial overload current safely. Then next is the conductor installed are to be safe in all respects. Then next is every subcircuit is to be connected to a distribution fuse board. Every line, that means phase or the positive line, is to be protected by a fuse of suitable rating as per the requirement. Switchboard is to be installed so that its bottom lies 1.25 to 1.5 meter above the ground floor. Then next is plug and socket are to be in 3-pin type. The appropriate pin of socket being connected permanently to the earthing system. Then all incandescent lamp, unless otherwise required, are to be hung at a height of 2.5 meter above the floor length, and ceiling fan are to be 2.75 meters above the floor. The lights and fan may be wired on a common circuit. Each sub-circuit is not to have more than a total 10 points of the light, fan and the socket outlet. The load on each sub-circuit is to be restricted to 800 watts. Then no fuse and switches is to be provided in the earthed conductor. Then every circuits or apparatus is to be provided with a separate means of isolation such as a switch. Then all circuit or apparatus required attention are to be provided with means of access to it. In any building, lights and fan wiring and power wiring are to be kept separate. In 3-phase 4-wire installation, the load is to be distributed equally on all the phases. So these are, then next is no additional load is to be connected to an existing installation unless it has been ascertain that the installation can safely carry the additional load and that the earthing arrangement are adequate. Lamp holder used in both rooms are to be constructed or shod in insulation material and fitted with protective shield, and the earth continuity conductor is to be size less than 7 by 0.915 mm. The metal sheet or conduit for all the wiring and metal covering of all the consuming apparatus or application is to be properly earthed in order to avoid the danger from the electrical shock due to the leakage or failure of insulation. The next is each sub-circuit is to be protected against the excessive current by fuse or the automatic circuit breaker. The next is all the light conductor are to be insulated or otherwise safeguard to avoid danger. After completion of work, installations are to be tested. The tests are not carried out as described before energization. Earth resistance should be low for the domestic installation. It should be equal to or less than 5 ohm to 8 ohm. And last is insulation resistance between the conductor should be very high for the domestic installation. It should be equal or more than 1 mega ohm, or it should be not be less than 50 mega ohm by the number of outlets. Thank you.